Greetings. Well, it's been a bit of a delay, but part 3 of my Amiga 500 rebuild is finally here. The delay was caused by Chinese delivery, of course, waiting for things to arrive. But things have arrived. I have done what needs to be done with them. I shall explain all that in just a moment. And my Amiga lives. Well, I say lives. It's just about usable. Okay, what I have now, I've connected up the keyboard. I've got this custom-made ribbon cable that I've put together for it, going to proper plugs, so I can swap the cable for a longer one, a shorter one, whatever I happen to need for how I do my final casing. That was easy enough, just crimping some JST XH connectors and soldering in some sockets. I have my minus 12 volt power inverter, which I've now wired in to power the audio chips, and I have my Gotek. The Gotek really is a lifesaver. If you're doing anything on any kind of retro computer, get a Gotek. That one was, I think it was £19 delivered from China. Came pretty quickly actually. I was expecting this to take about another week, but hey, it came early. So, where are we up to with this? Start off with the power inverter. I've rejigged the cabling of the power a little bit just to make it a bit less likely to short everything out. This power system I would actually like to replace with a custom PCB that will sit just on the main circuit here, replacing this choke to give a direct 12 volt input. So a future stage of this build I will be designing a new power circuit to go in there. It'll solder straight in where the choke solders in. But yes, I've now got minus 12 volts. This inverter is overly complicated for what I want. I'm going to have a little close-up on these in a moment and describe how they work. But that one is far too complicated for what I need, so in my finished circuit I'll be able to simplify that right down to just a few components. So that means that I've now got proper power to the audio chips, so I can now get sound. To that end, I've also wired in the audio outputs into my HDMI converter board. The Gotek, the first thing you need to do with a Gotek is change the firmware on it. It's very easy to do. Yes, you have to dismantle it and do a bit of soldering. The only soldering you need to do is to solder on some headers here. Let me just zoom in. There we go. This bank of headers here is not there when you get it, so you need to solder those in. One jumper on the side here switches it into bootloader mode, and then you can flash the firmware through a USB to UART adapter. It takes about 10 minutes to do. One other vital thing that you really should do as well is to upgrade the display. I mean, the Gotek normally comes just with a little 3-digit 7-segment display for the front panel, which is fine if you've got a handful of disk images on there, which is what it's really aimed for. But when you've got lots of files on there, all different things, you need to have a proper display on there. So this one I've upgraded with just a little OLED screen, cheap little Chinese SSD 1306, 0.91 inch. It's 128 by 32 pixels, I think they are. It'll also support 128 by 64, but you don't really need that. This only costs something like £2 on eBay. Connecting this in is literally just the same wires as this, just spread out sideways. It's all I2C, so 4 connections from there to the existing pins inside there, and the newer firmware just identifies it, picks it up and uses it. So one other small modification that I've done is my expansion RAM here is normally fast mem, or slow mem actually. It's slow fast pseudo fast mem. What I've done is change this to be another 512 kilobytes of chip mem, the same as this. That basically means that the system can handle more sound samples, more graphics, etc. And when I've done my memory expansion that I hope to do, I've got more on that in a moment, then having more chip RAM would be more important than having the fast mem, because the fast mem will be on the external expansion. So the actual way of converting this is very simple, but it does mean modifying the main circuit board. Basically there's two jumpers. There's one up here, JP2, and one here, JP7A. It's simply a case of cutting a trace on the lower two pads of JP2 and soldering the upper two together, and on JP7A just cutting the track between the two lower connections. As easy as that. It's cut, cut, one solder, and suddenly this becomes chip mem rather than fast mem. Right, what else have I got? I think that's everything that I've done so far on here. So now I'm going to boot up. I've got lots of ADF images on here, including the currently loaded one is memory test, which is a little ADF that I've put together from a couple of little programs off the good old Aminet. So I shall bring the screen up. Let's just focus on that. I'm going to turn my overhead lights off for the moment. And we shall see what we get when I plug in. Booting up. And the Gotek lights up. I'll show you the display on that in a moment. And we're into Amiga DOS. Testing memory. First test passed. Second test passed. There we go. Third test with AA. And that passed. And the last test with 5555 pattern. Done. Memory test completed, naught errors found. And if I do avail for the available memory, you can see that we have 1 megabyte of chip memory now rather than fast memory. Result. The Gotek, while the light is off, I can get a better view of this. Let's bring this up here. It shows you on the display what file it is you've got loaded, what track number you're on. If I do a reboot, I can do that with my one hand there. There we go. As it boots, you can see the track number and head number being displayed as it's loading. Buttons here allow you to choose which file. So handy. So actually, if I were to now go up a level and come down to demos, let's have the good old classic 9 fingers. And we reboot back to the screen. Focus. Go. And fingers crossed. Good old ham imagery there. Hold and modify. Still loading. It takes a while to load. Even though this is much more high tech than a floppy drive, the Gotek still only runs at the speed of a floppy drive, because it's completely emulating one. So you don't get any acceleration. But there we go. Let's If I can get this a little brighter. Not while recording. There we go. Good old 9 fingers. Considering this was created in the, I think it was 92 or somewhere around then, by just a group of Norwegian teenagers. It's an absolutely phenomenal bit of programming, and they were really, really talented guys, these Spaceballs, I think they went by the name of. They did this amazing demos. It all fitted onto 2 floppy disks. I mean, real-time, full-motion video, banging soundtrack. It's just onto disc 2, a stunning bit of coding. The demo scene back then really was huge. It's still around now, but it's nothing by comparison. Yes, these little power inverters, and this, as I say, this one is far, far more complicated than I need. They're very, very simple and yet very clever devices. How do you go about creating a negative voltage from a positive one? You may think that that sort of thing is going to be incredibly hard, but actually no, it's not. The system that most of them use is called a charge pump system, and it's just switching a capacitor. It's as simple as that. The basic idea is you have a positive voltage and a ground there. I have a positive voltage which goes in to charge a capacitor. Okay. So I can focus that a bit better. So you charge up a capacitor, as simple as that. Then, here's the cunning part. You disconnect that capacitor. The capacitor, of course, being a capacitor, holds its charge. Then you move that capacitor and you connect it so that the positive side of the capacitor is then on the ground. That's still ground there, but here you now have a negative voltage, because the voltage difference between here and here is the incoming voltage. By just moving it down, you've got the same voltage difference between here and here, but now the higher voltage is the ground reference, and the lower voltage is now below ground. So you've now got a negative voltage. That can then go off to power your device very briefly. So what's normally then done is you have a second capacitor here. Let's draw that one in there. So when you switch the capacitor from here to here, this capacitor then just pumps all its charge into there. So you charge it up here and then you pump it into there. So it's a charge pump. And then once that's been charged, you connect that capacitor back up there again, charge it up again, bring it back down, pump it into there, over and over and over and over again. The faster you can do it, the smoother the charge in there will remain. And these ones also contain a buck boost voltage regulator, switching regulator, which allows you to tune the output of this to anything from minus 1.2 volts up to minus, or down to minus 15 volts. I don't need that, but it's all I could get at a moment's notice on eBay. It has a tiny, tiny little trim pot on here, which is nigh on impossible to actually get a specific voltage out of. So I think on my Amiga I've got it set to somewhere around between 11 and 12 volts ish. But since I'm putting 12 volts in and I want minus 12 volts out, I don't need any of that switching regulation. I can just have the charge pump inverter. So 90% of this can go just a control. It'll just be a controller chip, a couple of capacitors, and that's about all it's really needed. So that's how that works. Now, on to my memory expansion ideas. I've been doing quite a lot of reading and looking at schematics and memory maps and what have you, and it's not going to be quite as simple and straightforward as I at first thought. The Amiga has an auto configuration system in it. Basically, when you connect a device to the expansion port, it first has to respond to a specific set of requests on a specific set of memory addresses to identify what the board is and what resources it needs. And then the Kickstart will send an address to the board for where the board should then put itself in memory. It makes life a little bit more complicated because I was hoping I could just create a block of memory and just place it in memory, and Kickstart would just go and look to see if there's memory in that location. Unfortunately, it doesn't. And there is an open source memory expansion available on GitHub, but it involves programming a CPLD to do all this magic for you, and I don't want that. I want to try and create this using just off-the-shelf Jelly Bean logic. No programming needed at all, which gets rather complicated. I've been experimenting in Logisim, and I think I have kind of created something, but I have to build it to actually find out if it works or not, and that's going to be quite a long-winded job. I've got a few other little bits in it that need sorting out yet, so I'll probably do an entire video just on that memory expansion actually coming up. Another thing I'd like to do, I've got a couple of flash chips here. These are 8-bit flash chips, and of course the Amiga uses a 16-bit data bus. What I want to do is upgrade the Kickstart, which is currently 1.3 on my Amiga, and I want to upgrade it possibly 204, possibly 3.1, I'm not sure yet. Of course the 1.3 is the last version in a 256 kilobyte ROM chip. Everything newer than that is half meg or whole meg in size. So this is actually, these two together will form the half meg in 16-bit wide that I should hopefully be able to put 204 onto. That'll be my first test anyway, to go 204 and possibly go to 3.1 afterwards. But of course that's going to mean building a circuit board to put these on. So I'll probably design a circuit board for that one and get it made. That again is going to take a while to come through from China. I could create my own on strip board or perf board perhaps, but I'd like to do these properly. And if I create a batch of them, then I should stick them online to sell as well for people that want to be able to flash their own Kickstart versions. So yes, that's future plans for that. Is there anything else that I want to do in the immediate future? Oh yes, the next big enhancement I suppose really should be the mouse. At the moment I do have mouse functioning, kind of. Let me just bring my Amiga back over. Because what I have, you may have noticed this bundle of wires out the side here. I've wired up to just a 9-pin plug a pair of cheap Chinese rotary encoders, which are functioning as horizontal and vertical mouse movement, and these have got built-in buttons as well, so pressing them for left and right mouse buttons. It allows me to get the mouse to move around, but it's very, very hard to actually do anything. I tried playing cannon fodder with it, and yes, the results were less than ideal, shall we say. I managed to do the first 2 levels, but you just can't move the mouse fast enough with these. So yes, my next major enhancement will be to turn this into an interface going via an Arduino or something similar into a PS2 socket that I can plug my PS2 mouse into, which is going to be fun but should be easy enough. It's mostly just reading the data through using pre-existing PS2 libraries and outputting pulses in the right sequence, basically. So yes, that is where we are up to at the moment. So I shall finish off today. I just rebuild my setup. It'll be so nice once it's all done and I can just plug it in and switch it on. And the power cable is here. Because I can now, even without anything like a proper mouse or a joystick or anything like that, I can do what I have been wanting to do for a long, long time. And that, hang on, where are we? Is, if I can find the right file on my Gotek. There we go. I shall need my mouse for this. Okay, that should be going now. This is what I have been looking forward to for so long. I cannot wait for a joystick to arrive so that I can get playing. You may recognise the music. My all-time favourite game, Turrican 2.